you ever, like, you've got biofilms growing, clearly you've got some great performance happening. Have you ever characterized, I'm big into characterization, so I'm curious what organisms might be benefiting you here.
We are doing quantum rate chlor, we are doing quantum rate petrol wherever we can.
Yeah.
As you know, you all have budgets. You know, I would love, hey, analyze for this, analyze for this. It's hard sometimes to get you to analyze for nitrates, dissolved metal, dissolved manganese and iron, for goodness sakes, with the budget. Yes, we are. We're doing research with Kate Procaryotic and Fatemeh Murdoch and Patel. We're doing research at Oklahoma State, Kansas State, Auburn. At each location, one of the really, really cool things about this is you take your DNA, RNA of the swimming planktonic population, plot it, and the expression comes out like a mosaic, like a Roman tile mosaic of color. I don't know what the real term of the analyses.
Well, that sounds like a heat map.
It's Dr. Shaylee Mahendra at UCLA was one of the first who had done this, and she showed me the data. She showed me the slides, but she can't share them because Dow owns them and blah, blah, blah. So then we took the same DNA, RNA expression analyses from the same population now in the biofilm. That scattered expression of DNA was a uniform flat. The colors lined up as a flat. What's that mean? The scattered mosaic was a whole bunch of selfish individuals doing their thing. There was a couple clusters of color, meaning they were cooperating a little bit here and there. The signaling was able to get close enough to them. But when they're in the biofilm, that same expression now lined itself up in the exact colors. That's uniformity. That's collective operation. That's the assigning of roles to benefit the population. Basically what a biofilm is, it's a collection of unicellular organisms creating structures, creating water channels. Water itself, bud, moves 100 times faster in a biofilm than it does in the bulk water. It's crazy. They make nutrient sinks. They make energy sinks. Through endogenous decay, they get sustainability. My chlorinated sites, I'll get you decades. I'll give you decades of sustainable reducing conditions. You're not going to put this in once. Petroleum sites are different. It's stoichiometry more at petroleum sites. So you are going to have to do some multiple injections. But I'll get you greater sustainability because we're getting into the biofilm. And so what this mass of unicellular organisms actually is behaving as, they're a multicellular organism. It's the precursor of the multicellular organism. They started doing this 4.3 billion years ago, and they haven't stopped. The anaerobes and the heterotrophs are more organized, more experienced, more prevalent than the aerobes. We breathe air, so it's got to be the best thing, right? It's not the best thing. It works. It's not the best thing.
Biofouling?
Biofouling is what happens when an aerated, oxygenated world comes in contact with a nutrient-rich slug of material. If you do a reducing world, if you're doing reducing work, and you have a pump and treat system nearby, I'm making an anaerobic, nutrient-rich world. If it comes into the contact and the influence of that pump and treat system where the water's moving fast, all the nutrients have been sucked out, anything beneficial is gone, and it's aerated because it's moving so fast, I'm going to foul that well like there's no tomorrow. Biofouling is yuck. Biofilm is a completely another world. Completely another world. Things don't go through fouling. Things go faster through biofilm.
Have you figured out what kind of radius of impact?
A lot of this, guys, basically, here's, real quick on that one. The site in Bridgeport, it's fractured weather sandstone. They had a rotary drill to put in, they did an injection, rotary drilled, and they thought they might get 30-foot AOI, 15-foot either side of that boring. We found after 7 years, it's still sustainable, still working. 105, it's now about 127 feet down gradient. We're getting 199% degradation of the parent-daughter ratio. 105 feet down gradient. What biofilms do, they mature. There is physical forces as the ground, it's a river. Groundwater is a river, a really complicated river. But as it matures and grows, it sloughs off, taking with it all those microbes. That goes through the pore channels, and if there's contaminant there and there's nutrient capability, they come to life and do their thing. 105, 120 feet down gradient. You're at a wastewater treatment plant. You live 5 miles south. Big rain event. I was a turd herder for years, so this happens. Big rain event. Overflows. Flock goes into the river. That's got untreated microbes in it. It travels 5 miles down the river. There's no nutrients in the water. There's nutrients, but they're going fast. You know, they can't do anything. All of a sudden, you're camping. Drink that little bit of flock was in that water. You are a nutrient-rich heaven. Boom! Guess what you got? Guess you're changing your underwear in a few hours, folks. Because those bugs who became a UMB and went dormant got into a nutrient-rich world and came to life. That's all I'm doing, is restoring the nutritive capacity of the environment. And it's not just throwing a whole bunch of nitrates. It's not going in and throwing a whole bunch of sulfate. This is an ecosystem. You know, we all want an answer. Well, what's the answer? I don't know. So the real neat thing is what we're doing right now. I'll shut up. I'm sorry. What we're doing right now, I swear I'll shut up. You went to a hotel, and Hannah's sick of this. You went to a hotel. Between you, there's this huge parking lot out your window and a bunch of railroad tracks between you and that parking lot. Close the curtains, go to bed all night long. Trains. You wake up, open the curtains, and that parking lot is full of cars. You can't say that train brought the cars. You didn't see it happen. How did the cars get there? I'm measuring AI2 signaling. I'm measuring protein. I'm measuring polysaccharides. I'm measuring all these new metrics that we all need to start looking at to do a better job. They all correlate to performance. There's no other answer. So,
All right.
thanks guys.
Yeah, thanks, Ken.